Bismillahirrahmanirrahim. So we have the lab 8 of analog to digital converter, in which we have to convert the analog signals into digital signals. So here we are going to use the analog sensor LM35 temperature sensor and convert the value of that analog sensor into digital and show the value on the LCD. So objectives of this lab: understand the function of ADC in microcontroller, learn different modes of operation of analog to digital converter, and integration of LM35 temperature sensor with ATmega 16. So first of all, we have to see the registers of analog to digital converter. Similarly, as in timers and counters, we have also the registers of analog to digital converter. So the operation of ADC, the ADC converts an analog input voltage to a 10-bit digital value through successive approximation. The minimum value represents ground and the maximum value represents the voltage on the ARF by minus 1 least significant bit. Optionally, AVCC or an internal 2.56 volt reference voltage may be connected to the A reference bit by writing to the A reference bit in the ADVAX register. So basically, the ADC is an analog to digital converter that is going to use the convert the value of analog sensors into digital sensors and show on the digital LCD. Now we will see the registers that are going to use in the ADC. So the first register in ADC multiplexer selection register, ADMUX. So multiplexer, as we studied in the DLD, the multiplexer is same as the depends on the selection lines. We are going to select the ADC selection. So here are the 7 registers in the AD MUX register: MUX 0, MUX 1, MUX 2, MUX 3 and up to REFS1. Now we'll see the table of these registers. Now you see that depending on the value of these MUX registers that are here in from 0 to 4. So basically 5 bits. Depending on the value of these 5 bits, our ADC conversion is selected. Whenever these registers are 000, then ADC 0 is selected. When 0001, then ADC 1 is selected, and similarly up to 1, 2, 3, 4, 5 up to 7. So depending on the values of these 0 to 4 bits, our selection ADC selection is selected. And the next 3 registers are AD LAR, AD left adjust right and right adjust right, and REFS0 and REFS1 is for the voltage reference selection. Whenever the values on the REFS0 and 1 is 00, then A reference internal V reference is turned off, and when the 01, then AVCC with external capacitor is enabled, and when the 10, then it is reserved, and when the REFS1 and REFS0 are both 11, then the internal 2.56 voltage reference with external capacitor A reference field. So in the task that I will show you the next, we are going to use the internal 2.56 voltage. After this, we have the register ADC control and status register, that is our ADC SRA, and we have the 7 bits in this, and each bit is represented by a single register. So the first ADC control and status register is AD enable, means ADC enable. Whenever the enable pin is 1, then we can convert any AD conversion. Whenever this bit is 0, then the ADC is turned off. After this, after enabling the ADC, we have to conversion start, means our next bit is ADC start conversion. In single conversion mode, write this bit 1 to 1 to start each conversion. ADSC will read as long as the conversion is in progress. When the conversion is complete, it turns to 0. Writing 0 to this bit has no effect. Mean, whenever we have to start the conversion of ADC, we have to given the value of 1 to the ADSC, and whenever the conversion is completed, automatically this register will go off. We do not have to set the value of 0 on this bit. After this, we have to auto trigger enable bit of ADC. When this bit is one, auto triggering of the ADC is enabled. Then our next bit is interrupt flag, means whenever the data is completely converted into digital, then the data registers are updated and this bit is set. The ADC conversion complete, interrupt is executed if AD enable bit and 1 bit and S registers are set. And after this we have the AD interrupt enabled. Whenever we have the conversion is completed, whether we have to enable the interrupt and ADC conversion complete interrupt is activated. Then after this we have the prescaler save as so we have already studied it, timers and counters. So these bits determine the division factor between the frequency and the input clock. We have the following registers in prescaler, that are ADPS21, 0, 1, 2, and 3, and depending on the values on these three registers, our prescaler value is selected. For example, when the all the registers are 000, then the division factor is 2, and when the 001, the division factor is 2, also 2, and when the 010, 4, 8, and up to 128 on the prescaler. So these are the registers that we are going to use in the ADC conversion and ADC. Now after this we have the task of our interrupt ADC temperature sensor, in which we have to convert the value of temperature that are going to use from LM35 and successfully convert the value of this analog sensor into digital and show the value on the LCD. So for this I have included the LCD library that I have used in previous labs also. After this, in the main function I am going to set the pin C as port C as an output, port F as an input, and port B also as an output. After this I have this ADC control status register 0x87 and ADC AD mark 0x30, means to start ADC status registers I am setting the and on depending on the value of AD marks I am going to select the ADC 0, 1, 2, 3, whatever the value is. Now after in the while function you see that to start the conversion I have given the value of 1 to the ADSC register. Now in the while condition you see that whenever the conversion is completed, then our interrupt flag is 1, and for this condition is executed and this condition is true, and then our this condition will execute. In this I have interrupt flag 1, means whenever the conversion is completed, then interrupt flag enables go off automatically. And now to show the value of the LCD in this, I have to convert the value in the digital value. For this I have used this formula that is given in the book chapter 13 of ADC conversion. Now this ITOA function is to represent the any integer value into the array value on the LCD. So to convert any integer value into array value, string value to represent it on LCD, we have to use the ITOA function, and after this I have passed the value of this into the LCD string function to show it on the LCD. Now I'm going to show you the practice simulation of this task. So here you see that I have made circuit for this task. Now I'm going to place the hex file here. Now I have set the hex file. Now I'm going to start the simulation. Now you see that the LCD is on, and after that whatever the value is set on this LM35, our value digital value will show it on the LCD. Sorry, my system is little slow, so that's why it takes time. Now I'm changing the value on the LM35 and the change will occur in the LCD. So basically this is our task of lab 8 of ADC conversion in the microcontroller using LM35 sensor. ये हमारा ADC वाला टेम्परेचर वाला LM35 वाला जिसमें हमने LCD का बना LM35 के थ्रू टेम्परेचर शो कराना था। मैं छोड़ के हाँ करे और बनाने दे मैं गरम कर